Good morning class, welcome to Jatin's Academy. So today in this class we will learn about the numericals of chapter 2nd, that is work, energy and power. These numericals I have taken from the book of concise physics Selina. So here we will see all solved and unsolved numericals. Now we have going to start the numerical based on different forms of energy. Now we have to see the numericals. So first of all we have to see the formula used in this chapter. So formula, if I am talking about first formula, I have potential energy as mgh. Kinetic energy formula I have half mv square. Next I have work done as force into displacement. Next formula we have momentum as mass into velocity. One more formula is there, which is a relationship between the kinetic energy and momentum, that is kinetic energy is p square by 2m. This formula we can directly use for the calculation of answers related to kinetic energy, momentum and mass. Now we have to start the solved examples from the book. So first example we have a body of mass 5 kg which is taken from a height of 5 meter to 10 meter. Find the increase in its potential energy if g value is given as 10 meter per second square. Means a body whose mass is 5 kg, okay, which is initially at a height of 5 meter, means initially the height is given as 5 meter. Now this body is taken from 5 meter to 10 meter height, okay. So final height we got it as 10 meter from the ground, okay. 10 meter from the ground we got height. So this body we have taken from a point to b point. Basically we have to find the increase in potential energy. Increase in potential energy we have final potential energy minus initial potential energy, okay. Final potential energy we have mgh final minus mgh initial. Mass we have 5 kg, g we have 10, and final height we have 10 meter, okay. And next we have mass we have 5 kg again, g value 10, and initially height we have 5 meter. We have taken it from 5 meter to 10 meter. So here we got 500 minus 250. So here we got it as 250 joule. So increase in potential energy we have 250 joule. Next we have a body of mass 1 kg fall from a height of 5 meter. How much energy does it possess at any instant? So for example, a body of mass 1 kg, okay, initially it is at a height of 5 meters from the ground. Now we have to calculate how much energy does it possess. So energy we have to calculate. Now according to the law of conservation of energy, energy at each and every point is same. So we can calculate energy at any point. Let's calculate the energy at this point, a point only. So at this point we have only potential energy. So energy at a point we have potential energy, which is mgh. Mass value we have 1 kg, g value we have 9.8, and height from the ground we have 5 meter. So from here we got it as 49 joule as a energy gained or energy at any instant. Clear? Next we have 500 liter of water is raised from the first floor of a house at a height of 4 meter to its third floor, which is at 12 meter. Okay, state whether the potential energy of water will increase or decrease. Find decrease or increase in potential energy of water. Take G as this and density of water as this. Now carefully see, water is initially at some height. Water is initially at some height which is 4 meter. Now water is raised from this first floor, okay, this first floor, it is raised to the third floor, okay, it is raised to third floor. Here the height from the ground is 12 meter, okay, height from the ground is 12 meter. We have to calculate the whether the potential energy will increase or decrease. Now carefully see, height will increase or decrease. So initial height we have 4 meter, final height we have 12 meter. So height is actually increasing, it means that potential energy is increasing. Now we have to calculate the increase in potential energy. how much this potential energy is increased, which is mg final height minus mg initial height. So mass we have here, mass is not given, here volume is given and density is given. We know that density is equals to mass per unit volume. So mass is equals to density into volume. So mass we have to calculate, density we have 1 kilogram per liter, means it is already given in liter, so no need to convert this volume into meter cube. Density is already given in liter, so we got the mass in kg. So 1 and 500 liter as volume. So here we got mass as 500 kg. Mass we have calculated. Now put the values. 500, g value we have 10, and final height we have 12 meter. Okay. Now again here 500, g value we have 10, and initially height we have 4 meter. So here we got 60 and 3 more zeros, minus here we have 20 and 3 more zeros. Clear? So here we got 40,000. This is energy, so joule. So here you can also write 10 raised to power 3 into joule, 40 kilojoule. So increase in the potential energy, we got it as 40 kilojoule. You can also write it in the zeros form, that is 1 2 3 4. So 4 into 10 raised to power 4 joule. In any way you can represent your answer. Clear? Next we have a block of mass 30 kg is pulled up by a slope as shown in the figure with a constant speed by applying a force of 200 Newton. Here 200 Newton force is applied parallel to the final position B, and this block is moved to this position B. We have to calculate the work done by the force in moving the block from A to B, and after that we have to find the potential energy gained by a block. G value is given, and we have to account the difference. In part 1 answer we will find the difference, and if any energy value will come, we have to check where this energy part is actually going, where it is wasted. So first we have block is given, 30 kg mass is given, with the constant speed it is moving, and force is given as 200 Newton. We have to calculate the work done by force in moving a block from A to B. A to B block is moving, we have to calculate the work done. Work done we have force into displacement. Force in this case we have 200 Newton, and displacement in the direction of force. This is very important. Work done if I am talking about, so force and displacement in the direction of force. Here we have two values of displacement, but in the direction of force we have 3 meter. So in this case work done we got is as 600 joule. So this is the work done by force in moving the block from A to B. Now we have to calculate the potential energy gained by a block. Potential energy gain, if I'm talking about potential energy, is mgh. Okay, this is the formula of potential energy. So at A point and at B point, if I'm checking how much the block is raised, we have to check the vertical height. So height in this case we have this BC line, which is 1.5 meter. Okay, mass of block is given as 30 kg and G value is given as 10. So mass is 30, G value is 10, and height we have how much? Height in this case we have 1.5. So here we got it as 450 joule. Now carefully see. Now in the B part, potential energy we have calculated. Now in the B part they are saying about account the difference in the answer in part 1 and part 2. Part A we have calculated work done as 600 joule. Okay, and in part B we have calculated 450 joule. Now if I just subtract it, I got 150 joule work done. Where this 150 joule work done is actually going? Now carefully see. When this block is moving on the inclined plane, total work done is 600. Out of 600, 450 is used to increase the potential energy, or I can say that 450 work done is required to raise the block up to the height of 1.5 meter or against the gravity. Rest 150 joule is wasted in friction, because friction force is also exerted by the plane on the block. So 150 joule of work done is, or energy is wasted in overcoming the friction. So this is basically a waste of energy. Next we have, in a dam, water falls at a rate of 1000 kg per second from a height of 100 meter. Calculate the initial potential energy of water, assuming 60% of this energy of falling water is converted into electrical energy. We have to calculate the power generated. Now how we will do, carefully see. So here first we will do calculate the initial potential energy. Potential energy we have mgh. Okay, so mgh, mass value we have how much, 1000. Now carefully see why I have taken mass as 1000. Mass here, so it is written rate means in 1 second 1000 kg of mass is falling. Actually water is not stagnant, water is moving. So what is the rate at which water is moving? That is, in 1 second 1000 kg of water is coming, okay, as a stream. So here I am taking mass for 1 second, I am taking mass as 1000. G value I have to take 9.8, and height from the ground we will take as 100 meter. So now when we will multiply, we will get it as 98, and we have basically 1 2 3 4 zeros. 1 0 is cancelled out here. Okay, this much joule. Or you can also convert 98 by 10 into 10 raised to power 4 into 10, that is 9.8 into 10 raised to power 5 joule. So this is the energy, which is the initial potential energy a water is having in 1 second. Now we have to calculate a next part, assuming that 60% of the energy of falling water is converted into electrical energy. So out of this total energy we are having 9.8 into 10 raised to power 5 joule. So out of this total energy, only 60% energy is converted into a electrical energy. So electrical energy I have 60% of total energy. 60% means 60 by 100. Total energy I have 9.8 into 10 raised to power 5. Clear? Now what we will do, we will solve this. So actually we got it as 6 by 10 into 98 by 10 and 10 raised to power 5. You can write like this. Okay, now cut 2 zeros. So here we got it as 588 into 10 raised to power 3. Okay, so this mass we are actually kilogram per second. So directly you can also write joule per second. Okay, joule per second you can write, because mass is not kg, it's kg per second. So you can also write like this, 588 divided by 100 multiply by 100 and 10 raised to power 3 as it is. Joule per second we have watt. Why? Because we know that power is equal to work done per unit time. Power is watt. Okay, work done we have joule and time is second. So watt is joule per second. So I can write here watt. So here we got it as 5.88 into 10 raised to power 5 watt. So this is the answer. This is the electrical power generated, which is 60% of the total energy. Next we have, a truck driver loads some oil drums into a truck by lifting them directly. Each drum has a mass of 80 kg and the platform of the truck is at a height of 0.8 meter above the ground. What force is needed to lift the drum into the truck? How much energy is used up in lifting a drum? After the truck is loaded, the driver drives off. List the major energy changes that takes place in moving the truck. And the driver stops the truck at the factory gate. What happens to the kinetic energy of the truck? These questions we have to give the answer. So let's just do the answers. First we have, a truck driver loads some oil. Okay, so we have to calculate force needed to lift a load. Means force we have to calculate, which is m into g. Means basically some mass is there and gravity is there. So force it is having a oil of mass 80 kg and G value it is given as 100. So force required, basically we need it as 800 Newton. Now we have to calculate how much energy used. Energy means work done. So work done we have force into displacement. Force we have already calculated as 800 and displacement we have 0.8. So when you will multiply, you will get 640 joule as your work done. Clear? Now we have to see the next question. After the truck is loaded and the driver drives off, list the major energy changes that takes place in the moving truck. Moving truck, initially it is stopped. When you on the truck, which energy is converted into which energy? Carefully see. In the truck, what we are using? Diesel or petrol? So diesel is converted and then it is converted into which energy? Mechanical energy. That's why it is moving. So here you can write, as a truck is moving, chemical energy of fuel, or we can say that diesel is changes into mechanical energy. Clear? Now the driver stop the truck at the factory gate. When the driver stop the truck, stopping means what? They have to apply the brake, and in the brake some heat is generated and some kind of sound is produced, and initially truck is moving with it is having kinetic energy. So next we have, when the driver stops the truck, on stopping the truck, the kinetic energy of a truck changes into heat and sound energy, which is produced when brakes are applied. Clear? Next we have to calculate the kinetic energy of body whose mass is 2 kg and moving with the speed 10 meter per second. So we know the formula kinetic energy as half mv square. Okay, half mass value we have 2 kg, velocity we have 10 square. 2 and 2 cancel out, 10 square we have 10 into 10 which is 100, and kinetic energy SI unit is joule. So 100 joule is the kinetic energy. Next we have, how fast should a man weighing 600 Newton run so that his kinetic energy is 750 joule. G value is given as 10. So in this question what we have to see, we have to calculate the fast, means we have to calculate velocity, and kinetic energy is given. So kinetic energy formula we have half mv square. Kinetic energy we have how much? 750 joule. Half is like this. Mass value we have here, mass is not given, here it is given weight. Weight we have m into g. Weight we have 600 Newton. Mass we have to calculate, g value is 10. So divide, mass we got it as 60 kg. So put the value of mass as 60, velocity we have to calculate. Now cross multiply. So 750 into 2 by 60. Okay, so this is a v square. Now cancel it out, what we will get? So here it is cancelled with 2 with 3 and it is cancelled with 25. So v square we got it as 25, which is v is equals to under root 25 square going to under root, which is 5. SI unit of velocity we have meter per second. So velocity we got it as 5 meter per second. Next question we have, how is the kinetic energy of a moving cart affected? First part we have, if its mass is doubled, and second we have its velocity is reduced to 1/3 of its initial velocity. Now if its mass is doubled, it means that its velocity remains same, and here its velocity reduced to 1/3, it means mass is same. So for example, initially we have a body of mass m moving with velocity v. So its initial kinetic energy we have half mv square. Now we have to calculate the energy when the mass is double. It means that we have to calculate the kinetic energy in terms of initial kinetic energy. So body whose mass is 2m, okay, whose mass is 2m moving with velocity v. So kinetic energy k dash I have half m, we got it as 2m v square. Okay, so now this 2 is taken out, so here we got half m v square. So this half m v square is nothing but basically a initial kinetic energy. So final kinetic energy K dash we have 2 times initial kinetic energy. So here I can write it as the final kinetic energy get doubled. And how much is the increase? So increase, if I'm talking about in kinetic energy, which is final kinetic energy minus initial kinetic energy. Final kinetic energy 2k, initial kinetic energy k. So increase in kinetic energy we have k, which is initial kinetic energy. Clear? Next we have the same question. Here mass m moving with velocity v. So kinetic energy we have half mv square. Now the next part, velocity is reduced to 1/3. It means that final velocity we have v by 3 reduced to 1/3 means 1/3 of an initial velocity, which is v by 3. So final kinetic energy we have k dash as half m value same v. Now new v we have v by 3. So here we got it as 1 by 2 half m v square by 9. Just take 9 as outside. So 1 by 2 half m v square. Half m v square we taken it as 1 by 9 into k. Okay, that is k by 9. So here actually kinetic energy decreases. In that part kinetic energy increases. Here kinetic energy will decrease. So we have to calculate now decrease in kinetic energy, which is initial kinetic energy minus final, means now initial kinetic energy is more and final kinetic energy is less. Initial kinetic energy we have k, final we have k by 9. So now just take a LCM, that is 9k minus k over 9, that is 9 8 by 9k. So the decrease in the kinetic energy we have 8 by 9th of initial kinetic energy. Next we have a truck of weight 5 into 10 raised to power 3 kgf and a cart of weight 500 kgf are moving with same speed. We have to compare their kinetic energy. So truck we are having, their weight is given as mass, I can say that 5 into 10 raised to power 3 kg. Why I am not writing as kgf? Because it is actually a weight. So in order to convert the weight into mass we have to divide it by g, but here they are using kgf, it means they are not using the value of g. So that's why I have written like this. Mass we have this is for truck, and for the cart mass we are having, this is, you can write truck, and this is for cart we have 500 kg. Now we have to compare their kinetic energy. Kinetic energy we have truck over cart, which is half m truck mass into velocity of truck square over half velocity mass of cart into velocity of cart. Okay, this half cancel out. Velocities they are moving with same speed, so same speed velocities are same, cancel out. Mass of truck we have 5 into 10 raised to power 3, I can write 1000, and mass of cart we have 500. So just cancel it out, cancel this 5. So here we got 10 by 1, so which is 10 ratio 1. So compare their kinetic energy, means kinetic energy of the truck is 10 times more than kinetic energy of a cart. Clear? Next we have, for same kinetic energy of a body, what should be the change in its velocity if its mass is increased 4 times? What is the meaning of this? Carefully see. For example, a body of mass m moving with velocity v having kinetic energy k, which is half mv square. Now in same case, or in the second case, we have to find the change in velocity. We have to find the new velocity, okay, whose mass is 4 times increased to 4 times of its initial mass, but kinetic energy remains same, which is k. So how this possible? Carefully see. Means this k dash and this k is same. Okay, k dash is equals to k. Now k dash we have half, mass we have 4m, and velocity we have v dash square. Okay, this v dash means new velocity. So just equate these equations. Half m v square is equals to half 4m v dash square. Half and half cancel out directly, mass and mass cancel out. So this 4 is going on the left side. So 4 multiply, divide here. So v dash square. Now this square become a root. So here we got v square by 4. Just separate this root. Okay, v square we write it as v and 4 we write it as 2. So v dash we got it as v by 2, means velocity is decreased to half. Okay, velocity is decreased to half. So here they are asking about what should be the change in velocity. So velocity gets half. Clear? Next we have very important question. A bullet of mass 5 gram travels with the speed of 500 meter per second. If it penetrates a fixed target which offers a constant resistive force of 1000 Newton to the motion of bullet, we have to calculate the initial kinetic energy of bullet, distance through which the bullet has penetrated before coming to rest, and speed with which bullet emerges out of the target if the target is of 0.5 meter thick. Now carefully see the question. Here we have a block, here we have a bullet. So bullet is moving with some speed, enter the block, reduces its speed, and it's come out with the less speed. As obvious, we have just seen in the movies also these types of things. When it is enter with more velocity, more energy, but this block is applying some resistive force on this bullet. So that's why when it is coming out, its velocity gets reduced. So we have to just give the answer based on this question. So now first we have to calculate the initial kinetic energy. Before entering to the block, what is the initial kinetic energy of a bullet? So initial kinetic energy I have half m initial velocity square. Vi means initial velocity square. Okay, so half mass we have 5 gram converted into kilogram. So 5 gram, when I convert it into kilogram, it is 5 by 1000 kilogram, which is SI unit. 5 by 1000 kilogram. Now velocity, the bullet of mass 5 gram travels with the speed of 500 meter per second. So initial velocity we have 500 meter per second. Now put the value 500, okay, square. Now just calculate 500 into 500 two times. So here 1 2 3, 1 2 and 3. So when you will solve this, you will get 625 joule as a initial kinetic energy. Clear? So initial kinetic energy we got it as a 625 joule. Next we have to calculate the distance through which the bullet has penetrated before coming to rest. So this block is there which is actually decreasing the energy of a or decreasing the speed of the bullet. Now we have to calculate when the bullet will enter, how much is the distance traveled by the bullet before coming to rest. Before coming to rest means what? Carefully see. This block is applying some resistive force which is 1000 Newton, and means this block is decreasing their energy. How much there is decrease in energy? So if I'm talking about block, how much they are decreasing the energy, so this is force into displacement. So resisting force we have 1000 Newton and displacement we have to calculate. Okay, means up to what distance this bullet will move, so that's its whole kinetic energy. Very important point, its whole kinetic energy is reduced to 0 by this block. So this whole block energy is converted into kinetic energy, or vice versa, means this whole kinetic energy is taken by the block. So kinetic energy we have already calculated, that is 625 joule. Force is 1000 and displacement we have to calculate. So displacement we got it as 625 by 1000, that is 0.625 meter, means up to the depth or up to what distance this bullet will penetrate before coming to rest. that is 0.625 meter. Clear? Next we have the speed with which the bullet emerges out if it targets of 0.5 meter. Now the thickness of the block is only 0.5 meter. So initially the bullet is moving with energy that is 625 joule. Finally it is coming out with some kinetic energy. Okay, final kinetic energy I don't know. So we have to calculate that energy. So where the another energy is wasted, another energy is taken by this block. How much this energy is taken by this block? So this energy is force into displacement. It means that if I'm talking about the conservation of energy we have initial kinetic energy, and this block is taking some energy, or I can say that block absorbs some energy, and after that it coming out with some final kinetic energy. Initial kinetic energy we have 625 joule. Block absorb how much energy? That is force into displacement. Force we have 1000, resistive force by this block 1000, and displacement, the thickness of the block is 0.5 meter. Final kinetic energy we have to calculate. So 625 minus 500, so final kinetic energy we got it as 125 joule. Clear? Now we have to calculate the velocity, final velocity. So final kinetic energy formula we have half m final velocity square. Okay, so here we have final kinetic energy as 125, 1 by 2, mass we have how much, 5 gram, which is 5 by 1000 kilogram, into velocity square. Now just cross multiply, velocity square we got it as 250, this 125 multiplied to 250 divided by 5 and multiply by 1000. So here it is 50 taking the root, so 55 into 4 zeros, 4 zeros coming out from the bracket, it become 100, and under root 5 is basically 2.236. So now multiply, so final velocity we got it as 223, that is 223.6 meter per second. So this is the final velocity with which the bullet comes out from the block. Clear? Next we have calculate the kinetic energy of a body of mass 0.1 kg and momentum is this. Here momentum and mass is given, we have to calculate kinetic energy. So direct formula we will use, that kinetic energy is equals to p square by 2m. P we have momentum we have 20 square, 2 into mass value we have 0.1, 20 into 20. Okay, this 2 is as it is, 0.1 I can write it as 1 by 10. So 10 is coming on the numerator. So here we got it as 10. So 2000 joule. Okay, kinetic energy we have 2000 joule or 2 kilojoule is the correct answer also. Next question we have, a ball of mass 10 gram falls from a height of 5 meter. It rebounds from the ground to a height of 4 meter. Find the initial potential energy of a ball, kinetic energy of a ball just before striking the ground. Next we have kinetic energy of a ball after striking the ground and loss in the kinetic energy on striking the ground. Take G value as 9.8. So here just carefully see the picture. So here ball is initially at some height. So this height is basically a 5 meter. Okay. So when the just ball coming out on the ground and just rebounds, it rebounds to a height of 4 meter. Okay. So basically we have to calculate the initial potential energy. Initial potential energy we have mg initial height. So mass we have, mass here we have 10 gram converted into kilogram, 10 by 1000. G value we have 9.8 and initial height we have 5 meter. Okay, just multiply this, we got 0.49 joule as a answer. When you will multiply, just cancel it out these things, you will got the energy as initial potential energy as 0.49 joule. Clear? Now we have to calculate the kinetic energy of ball just before striking the ground. So when the ball, which is at a height of 5 meters from the ground, when it is moving, we have to calculate the kinetic energy here. Means here what is the kinetic energy? So according to the conservation of energy at this point and energy at this point is same. Before touching the ground, what is the kinetic energy? So potential energy is completely converted into kinetic energy according to the conservation of energy. So potential energy we have already calculated. At this point we have 0.49 joule. So kinetic energy before touching the ground, before striking the ground, kinetic energy is same, that is 0.49 joule. Next we have the kinetic energy of ball after striking the ground. Now carefully see the question. When the ball, which is initially at 5 meter, is touching the ground, so before touching the ground whole kinetic energy is converted, but when it is rebound, it is not rebound to initial height. If it is not rebounds to initial height, then there is some loss in energy. So first we have to calculate what is the kinetic energy of ball after striking the ground. After striking the ground, kinetic energy is equals to the potential energy up to or height up to which the ball is raised. So according to again conservation of energy, kinetic energy after striking is equals to potential energy after the height gained, means final value I'm talking about. Kinetic energy we have potential energy final, which is mgh final. Mass we have, mass in this case again 10 by 1000. G value we have 9.8. And final height is not 5 meter, it is only 4 meter. So when you will multiply it with 4, you got answer 0.392 joule. Clear? So this is the potential energy, or this is the energy at which ball is raised, and this actually a kinetic energy when it strike and bounce back. So this ball is initially having kinetic energy, so this kinetic energy is actually converted into a potential energy. So here I can write that the whatever the potential energy we are getting, that is just a kinetic energy at this point. Now we have to calculate the loss in kinetic energy. Loss kinetic energy we have, that is initial kinetic energy how much we have and final kinetic energy value. So initial kinetic energy we have calculated as 0.49 and final kinetic energy we have 0.392. So loss in kinetic energy we got it as 0.098 joule, which is a small value, but this energy is because when the ball is strike on the ground, some type of heat is released in the environment when it is touching or rubbing with the ground, and some type of sound is produced. So that energy is actually lost. So that's why the raised height is less than the actual height. Next we have a spring is kept compressed by a toy cart of mass 500 gram. On releasing the cart, it moves with the speed this. Calculate the potential energy of a spring. For example, with the spring, some toy cart is attached. It is actually a attached, means it is compressed. When it is released, it gains some velocity, means it gains some energy, which is 0.2 meter per second is the velocity, and it is having mass 150 gram. So we have to calculate how much energy is stored in the spring. According to conservation of energy stored in the spring is actually how much energy is gained by the block after releasing, which is equals to kinetic energy. So energy stored in the spring we have kinetic energy. Kinetic energy we have half mv square. So half mass value we have 150 gram, just convert it into kilogram divided by 1000. Velocity we have 0.2 square. So just quickly solve this. So 0.2 means 2 by 10 into 2 by 10. So just cancel out. So here we got 30 and one more cancel out. So here we got 3 and 1 2 3 0. So this much joule, or I can write it as 3 into 10 raised to power minus 3 joule. So this is the actually the energy stored in the spring, and this is also kinetic energy. It means energy stored in the spring, which is elastic potential energy, is converted into a kinetic energy. Clear? Numerical based on different forms of energy. Now we are going to start the unsolved numericals. So first numerical we have two bodies of equal masses are placed at a heights h and 2h. Find the ratio of their gravitational potential energy. So two bodies we have having equal mass. One body is having mass m, another body is also having mass m. But they are placed at different heights. One is placed at h height from the ground and one is placed at 2h height from the ground. We have to find the ratio of their potential energy. Potential energy formula we have mgh. Clear? So potential energy of first case over potential energy of second case, which is equals to mass of first body g into height of first body over mass of second body into g into height of second body. G and g cancel out here. Mass is also same, so you can write m. Height we have first case h and second case height we have 2h. So mass and mass cancel out, h and h cancel out, so we got 1 by 2. So potential energy of first case in first case over potential energy of second case ratio, we got it as 1 by 2, which is 1:2. Next we have find the gravitational potential energy of 1 kg mass kept at a height of 5 meter above the ground. Here again we have to calculate the potential energy of mass 1 kg. Mass 1 kg, a body of mass 1 kg, height is given as 5 meter and g value is given as 10 meter per second square. Potential energy formula we have mgh. Mass value we have 1, g value we have 10, h value we have 5. So here we got 50, and the SI unit of gravitational potential energy is, it is a form of energy, so answer is in joule. So 50 joule is the answer. Next we have a box of weight 150 kgf has a gravitational potential energy stored in it is equals to 14,700 joule. Find the height of the box above the ground. So here in this case it is given as force is given as 150 kgf. It is given in kgf and potential energy is given as 14,700 joule. We have to calculate the height, okay, and g value is given as 9.8 meter per second square. So here again we will use the formula potential energy as mgh, okay, but before that we have to convert this force into a Newton SI unit. So force here we have 150 into g value. G value it is written as 9.8. So multiply this, you will get it force as 1470 Newton. So here force is given as 1470 Newton. This force is actually a weight which is mg. So mg value is given as 1470 Newton. Now put the value here. Potential energy mgh, potential energy we have 14,700, mass m into g we have 1470 into h. So h value we have this divided by this. So here we will cancel out and we will get only 10. Okay. So here height we got it as 10 meter. Clear? Next we have a body of mass 5 kg fall from a height of 10 meter to 4 meter. Calculate the loss in potential energy of body and total energy possessed by a body at any instant. So here a body of mass 5 kg, a body of mass 5 kgs fall from a height of 10 meter. Initially the body is at a height of 10 meter and falls to a height of 4 meter, means total there is 6 meter covered by the ball. Now we have to calculate loss in potential energy. So at here we have first potential energy, here we have second potential energy. At first point potential energy we have mg, first height, mass we have 5, g value we have 10, and height initially we have 10. So here we got 500 joule. Next we have potential energy at second point. Potential energy at second point we have mass g, height at second point. Mass we have again 5, g value 10, and height we have from the ground, here if we will see, that is 4 meter. So here we got it as 200 joule. Now we have to calculate the loss in potential energy. Loss in potential energy we have potential energy at first point, means at the maximum point, to the potential energy at minimum point to second point. So here we got 500 minus 200, which is 300 joule. Now we have to calculate the total energy possessed by body at any instant. So at any instant, if they are talking about, you can also calculate at first instant. So at first instant total energy, if I am talking about, it is only a potential energy, because here kinetic energy is 0, but at the second point kinetic energy is not 0. Here kinetic energy is 0, so I can say that total energy in the body is equals to potential energy at first point, which is we have calculated as 500 joule. So total energy of a body we have calculated as 500 joule. Next we have calculate the height through which body of mass 0.5 kg is lifted if the energy spent in doing so is 1 joule. Take g value as 10. So here they are talking to find the height. We have to find the height. A body of mass 0.5 kg which is lifted above, and energy is spent in this case, which is a form of potential energy, is 1 joule, and g value is given as 10. So now we have to calculate the height. Potential energy formula we have mgh. Potential energy value is 1 joule, mass value is 0.5 kg, g value is 10, and height value we have to calculate. So 1, this is 5 by 10 into height. So cancel it out. So here we got height value as 1 by 5 meter. So now convert it into centimeter. Converting 1 by 5 meter into centimeter, multiply by 100. So 100 by 5, we got height gained by a body have 20 centimeter. Clear? Next we have a boy weighing 25 kgs climbs up from a first floor at a height of 3 meter above the ground to the third floor at a height of 9 meter above the ground. We have to find what will be the increase in gravitational potential energy. Initially, the boy whose mass is given as 25 kgf is on the first floor, which is at a height of 3 meters from the ground. Now the boy raises up and go to the third floor, which is 9 meter. So here it is 9 meter above the ground. We have to find the increase in potential energy. Here potential energy, for example, 1, here potential energy 2. So potential energy increase, if I am talking about, increase means what is the final potential energy to what is the initial potential energy. So if I am talking about the formulas, final potential energy we have mg final height, because mg is same. Here mg is given as 25 kgf. Mass weight, which is equals to force, is given as 25 kgf. Converting kgf into Newton, we have to multiply with g, and g value is given as 10. So 25 into 10, we got it as 250 Newton. So force value, which is weight or mg, is 250 Newton. So mg we have 250. Second height we have 9 meter. So when you will multiply 250 into 9 meter, you will got 2250 joule. Now we have to calculate potential energy at first point. So here again mgh1. Mg value we have 250 and height we got it as 3 meter. So 250 into 3 meter, we got it as 750 joule. Now we have to calculate increase in potential energy. Increase in potential energy we can also write with delta P is equals to PE2 minus PE1. Okay, final potential energy minus initial potential energy, which is 2250 minus 750. So when you subtract it, you will get increase in potential energy as 1500 joule. So in this case, what will be the increase in potential energy? Increase in potential energy, we got it as 1500 joule. Clear? Next we have a vessel contain 50 kilogram of water is placed at a height of 15 meter above the ground. Assuming the gravitational potential energy at the ground to be zero, what will be the gravitational potential energy of water in the vessel? So here they are saying that a water is placed above the ground whose mass is 50 kg, okay, and placed above the ground at a height of 15 meter. So here we have to calculate the potential energy stored in the water. Potential energy formula we have mgh. So here at the ground potential energy is 0. So here we will not take any potential energy. So mass value we given as 50, g value it is given as 10, and height value it is given as 15 meter. So when you will multiply 15 into 5 into 10, so here you will got it as 7500 joule. So potential energy stored in the water which is placed in a vessel above the 15 meter height is called 7500 joule. Clear? Next we have a man of mass 50 kg climbs up a ladder of height 10 meter. Calculate the work done by a man and the increase in his potential energy. G value is given as 9.8 meter per second square. So a man of mass 50 kg, mass is given as 50 kg, climbs up a ladder of height. Height is given as 10 meter and G value is given as 9.8. First of all, we have to calculate the work done by a man. So work done, we have force into displacement. Force in this case we have mass into gravity, F value which is equals to weight is equals to m into G, and displacement in this case we have 10 meter which is height. So in this case, work done by a man, and what is the formula of this mgh? It is equals to potential energy. So work done and increase in potential energy is same in this case. So we will calculate only one value as mgh. So both answer is same. Mass value we have 50, g value we have 9.8, and h value we have 10. So from here we got it as 4900 joule. So the gain in potential energy or work done by a man, both answer is same, that is 4900 joule. Clear? Next we have a block of weighing 100 Newton is pulled up a slope of length 5 meter by means of a constant force of 100 Newton as shown in figure. What is the work done by a force in moving a block 5 meter along the slope? Second part we have what is the increase in the potential energy of block, and third we have to see the account for the difference of work done for the first part and the increase in the potential energy we have calculated in the second part. So first we have to calculate the work done by force. So this force is applying in this direction and displacement occur in this direction. Okay, so here you will calculate work done as force into displacement. Here you will not take any cos theta angle. Why? Because force is applying in this direction and displacement also occur in this direction. So angle between them is 0 degree. They are in the same direction. Force value is given as 100 Newton and displacement along this rough inclined plane is 5 meter. So work done by the force is 500 joule. Clear? Now we have to calculate the increase in potential energy. Potential energy we have mgh. Okay, in this case mg is acting as a force and height we have to take. Height always take vertical height. Force we have 100 Newton and vertical height, if I'm talking about vertical height in this case is this value bc which is 3 meter. So here we got increase in potential energy as 300 joule. Now we have to see account for the difference in the work done. First we have to calculate work done. We have calculated as how much? 500 joule, and potential energy we have calculated as 300 joule. Now we have to take the difference. When we will take, we got 200 joule. What is the meaning of this 200 joule? The meaning of this 200 joule is that there is frictional force acting along the or acting on the block. As a frictional force is acting, to overcome the friction, some energy is required. So this 200 joule energy actually represent that it is overcoming the frictional force. Clear? Next we have find the kinetic energy of body of mass 1 kg moving with the uniform velocity 10 meter per second square. So here we have to calculate the kinetic energy. Kinetic energy we have half mv square. Okay, mass value is given as 1 kg and velocity is given as 10 meter per second. So 10 square, so 1 into 1 into 10 square means 10 into 10. So here we cancel out. So we got kinetic energy as 50 joule. So kinetic energy we got it as 50 joule. Clear? Next we have, if the speed of car is halved, how does its kinetic energy change? For example, of body of mass m moving with velocity or speed v. Now in second case, mass is same. They are not talking about mass, but they are saying that their speed is half, means velocity is v by 2. Now we have to calculate how is the kinetic energy change. For example, initially kinetic energy we have half mv square, and final kinetic energy which is represented by k dash is half mv by 2 square. Okay, so here v by 2 square, when we will multiply it become v square and 2 square. Okay, v square and 2 square, here I can write v square and 2 square. 2 square we write it as 4. Take 4 outside common, 1 by 4 mv square. So half mv square we have equals to this kinetic energy k. Okay, so k dash we got it as 1 by 4k. So here we can write k dash is 1 by 4k. It means that by making the velocity half, kinetic energy becomes 1 by 4th of initial kinetic energy. Clear? Next we have calculate the decrease in the kinetic energy of a moving body if its velocity reduces to half of the initial velocity. For example, a body of mass m moving with velocity v. Now a body reduces its velocity. Mass is same but velocity reduces to half of the initial value. We have to calculate the decrease in kinetic energy. So initial kinetic energy we have half mv square, and here final kinetic energy we have half mv by 2 square. Okay, so k dash we have half mv square by 2 square, which become half mv square by 4. So k dash we got it as 1 by 4 common, 1 half mv square. So this is half mv square, we can take it as k. So k dash we taken it as 1 by 4 k. Now we have to calculate what is the decrease. Decrease means initial kinetic energy minus final kinetic energy, because initial kinetic energy is more and final kinetic energy is less. That's why we are taking initial kinetic energy at front and final kinetic energy at the right side, because initial kinetic energy is more. Initial kinetic energy we have k, final kinetic energy k dash we have 1 by 4k. Okay, so take the value LCM. 4 LCM we got, which is 4k minus k, this is 3k by 4. So here if they are talking about decrease in kinetic energy, we have 3/4 of the initial kinetic energy. So decrease value we got it as 3/4 of the initial kinetic energy. Clear? Next we have two bodies of equal masses are moving with uniform velocities v and 2v. Find the ratio of their kinetic energy. So two bodies having equal mass. First body is having mass m, second body is having mass m. First moving with velocity v, second moving with velocity 2v. Now we have to calculate the ratio of kinetic energy. Before that, calculate kinetic energy. In first case kinetic energy we have half mv square, and in second case kinetic energy we have half m 2v square. So here 2v square means 2 square and v square. Okay, so 2 square means 4 and v square as it is, so cancel it out. So here we got it as 2mv square. So now we have to take the ratio of their kinetic energies. So ratio of their kinetic energy we have half mv square over 2mv square. So from here 2 is multiply here, so 1 by 4 mv square over mv square. So this mv square cancel it out. So kinetic energy in first case over kinetic energy second case we got it as 1 by 4. So ratio we got it as 1:4. Clear? Next we have a car is running with the speed of 15 km per hour while another similar car is moving with the speed of 45 km per hour. Find the ratio of their kinetic energies. So one car whose mass is m moving with velocity 15 km per hour, and second car whose mass is again m moving with 45 km per hour. Now we have to calculate the ratio of their kinetic energies. So if I'm talking about ratio of kinetic energy, first of all we have to convert this velocity into its SI unit, which is meter per second. So convert this. So 15 converting kilometer per hour into meter per second, divide multiply by 5 by 18. Okay, so here we got it as 5 and 6, so 25 by 6 meter per second. So here 45 multiplied by 5 by 18. So here we got it as 15 over 6 and next 5 over 2. So here we got it as 25 by 2 meter per second. Now we have to calculate kinetic energy in this case, which is half mv square, 25 by 6 square. Okay, here we have to calculate kinetic energy. Half mv square means 25 by 2 square. Now no need to open this, just directly take the ratio because it is cancel it out. Half m 25 by 6 square over half m 25 by 2 square. So half m cancel out. So here we got 25 square over 6 square divided by 25 square over 2 square. So here 6 is multiplied with denominator and 2 square is multiplied with numerator. 25 square into 2 square divided by 25 square into 6 square. So here it is cancel out. Here it become 4 and 36. 4 and 36 cancel with 9 table. So ratio we got it as 1:9. Clear? Next we have a ball of mass 0.5 kg slows down from a speed of 5 meter per second to 3 meter per second. Calculate the change in kinetic energy. So they are talking about change in kinetic energy. Change in kinetic energy represented with delta is final kinetic energy minus initial kinetic energy. So final kinetic energy we have half m final velocity square minus half m initial velocity square. So final velocity we have 3 meter per second and initial velocity we have 5 meter per second. Now let's calculate the value of kinetic energy from these velocities. So initial kinetic energy we have half m, mass value we given as 0.5 kg, into initial velocity. Initial velocity we have 5 meter per second means 5 square. So when we will multiply, here it becomes 0.25 into 25. So here we got 25 into 0.5, so 6.25 joule. Clear? Now we have to calculate final kinetic energy. Final kinetic energy we have half m, again 0.5, velocity square means 3 square. So 3 square here it is become 0.25 and 3 square we commit as 9. So 0.25 into 9. So here we got 2.25 joule. Now we have to calculate the increase in kinetic energy or change in kinetic energy. Here velocity is actually decreasing, so kinetic energy decreases. So change, if I am talking about final, we have 2.25 minus initial we have 6.25. So 2.25 minus 6.25, so answer we got it as minus 4 joule. It means that here kinetic energy decreases. So change in kinetic energy or decrease in kinetic energy, we can write it as 4 joule. You can also write decrease. Next we have a cannonball of mass 500 gram is fired with the speed of 15 meter per second. Find its kinetic energy and its momentum. So a cannonball whose mass is 500 gram, which is 500 by 1000 kilogram kg. So here we got it as 0.5 kg and speed or velocity is given as 15 meter per second. We have to calculate the kinetic energy. Kinetic energy we have half m v square. So half mass value is given as 0.5 and velocity is given as 15 square. So here again it becomes 0.25 this and 15 square 225. So 225 into 0.25 we got it as 56.25 joule. Clear? Now we have to calculate momentum. Momentum we have mass into velocity. Mass 0.5 and velocity we have 15. So 0.5 into 15 we got it as 7.5. And SI unit of momentum we have kilogram meter per second. Kilogram is mass, meter per second is a velocity. Clear? Next we have a body of mass 10 kg moving with the velocity 20 meter per second. If mass is doubled and velocity is half, find the initial kinetic energy and final kinetic energy. So in the first case, a body of mass 10 kg moving with the velocity 20 meter per second. Next case, if mass is doubled. In second case, mass is doubled means 20 kg. Okay, mass is doubled 20 kg and velocity is half. Half means 20 is there, half means divided by 2, so 10 meter per second. Now we have to calculate initial kinetic energy. Here it is an initial case. Initial kinetic energy we have half m v square, initial velocity square. This is initial velocity, this is final velocity. Initial mass, final mass, initial mass. So initial kinetic energy we have half, mass is 10, velocity we have 20 square. Okay, so here we got it as 5. So 5 into 400. So here we got it as 2000 joule. Clear? Now we have to calculate the final kinetic energy. Final kinetic energy we have half final mass into final velocity square. So final kinetic energy we have half, final mass we have 20 and final velocity we have 10 square. Okay, so here it is cancel out 10. So 10 into 100, which is we have 1000 joule. So initial kinetic energy we have 2000 joule, and in the second case when mass is doubled and velocity is half, kinetic energy is reduced to 1000 joule only. Next we have a truck weight 1000 kgf changes its speed from 36 km per hour to 72 km per hour in 2 minutes. We have to calculate the work done by engine and power. So according to work energy theorem, work done is equals to increase in kinetic energy, which is final kinetic energy minus initial kinetic energy. Now we have to calculate work done, which is equals to increase in kinetic energy. Final kinetic energy, for that we need a final velocity, and initial kinetic energy we need a initial velocity. So 36 km per hour is actually a initial velocity which we will take in the meter per second, which is 5 by 18. So here it is cancel out. So initial velocity we have 10 meter per second, and final velocity, if I'm talking about final velocity, we have 72 km per hour, which is 72 into 5 by 18, which is 420 meter per second. We have calculated the velocities. Now let's calculate the kinetic energy. But before that we have to calculate the mass. So here mass is given as 1000 kgf. So 1000 kgf it is given, which is equals to weight. Okay, actually it is given mg. Kgf means 1000 into g. So from here g and g cancel out. Mass value is given as 1000 kg. Now let's calculate the energies. Final kinetic energy we have half, mass we have 1000, and final velocity we have 20 square. 20 square we got it as 400 over 2, which is 200 into 10 raised to power 3 joule, which is also called 200 kilojoule. I am directly writing as 200 kilojoule. Clear? Now we have to calculate initial kinetic energy. Initial kinetic energy we have half, mass 1000, and velocity we have 10 square. So 10 square is actually 100. So 100, which is cancel it out with 50. So 50 into 10 raised to power 3 joule, which is 50 kilojoule. Now we have to calculate the work done, which is final kinetic energy. We got it as 200 kilojoule. Initial kinetic energy we have 50 kilojoule. So work done we got it as 150 kilojoule. So at the end work done we got it as 150 kilojoule. Now we have calculated work done as 150 kilojoule, which is equals to 150 into 10 raised to power 3 joule. Now we have to calculate power. Power we have work done per unit time. Work done we got it as 150 into 10 raised to power 3, and time it is given in 2 minutes. Minutes, let's convert it into seconds. So in 2 minutes we will have 2 into 60, which is 120 seconds. So 120 seconds. So cancel it out. We got it as 5 by 4. Okay, 5 by 4 we have 1.25. So into 10 raised to power 3 watt. Or okay, so here it is multiplied, so it become 1250 watt. So power we have calculated as 1.25 into 10 raised to power 3 watt, or you can also write 1250 watt. Next we have a body of mass 60 kg has a momentum 3000 kg meter per second. Calculate the kinetic energy and speed of a body. Mass is given as 60 kg and momentum is given as 3000. We have to calculate first we have to calculate kinetic energy, then we will calculate about the velocity or speed. Now direct formula we can use, that is kinetic energy is equals to P square by 2m. Okay, P square means 3000 square over 2 into mass value we given as 60. So it means 3000 into 3000 divided by 2 into 60. So here we got it as 50, which is multiplied with 25. So here we got 25 into 3, which is 75 into 10 raised to power 3 joule, or you can write it as 75 kilojoule. Now we have to calculate speed. Speed we will have momentum is equals to mass into velocity. So velocity we have momentum over mass. Momentum is 3000 and mass is 60. So here we got speed it as 50. So velocity or speed we can write it as 50 meter per second. Clear? Next we have how much work is needed to be done on a ball of mass 50 gram to give its momentum of 5 kilogram per second. So here mass of ball is given as 50 gram, which is 50 by 1000 kilogram. So this value we got it as, cancel it out, 1 by 20 kilogram, and momentum is given as 5 kilogram meter per second. Okay, now we have to calculate how much work in this case we will calculate kinetic energy. So here kinetic energy and work done is same. So kinetic energy in case of momentum formula we have p square by 2m. P square means 5 square into 2, and m value we have 1 by 20. So here it is cancel out 10, so this become 25 and 1 over 1 by 10. So denominator of denominator become numerator. So 250 joule is a kinetic energy, or 250 joule we can write it as a work done. So work done we got it as 250 joule. Next we have how much energy is gained by a box of mass 20 kg when a man carrying the box wait for a minute, 5 minutes for a bus. Second, run carrying the box with the speed 3 meter per second to catch the bus. And last, raises the box by 0.5 meter in order to place it inside the bus. G value is given as 10. Now carefully see, we have to calculate the energy in different cases. First case we have carrying a box, wait for 5 minutes for a bus. A man is standing on the stop and waiting for the bus. In this case displacement is 0. As displacement is 0, work done is force into displacement. Although the boy is carrying a box, means weight is there, force is there, but displacement is 0, so that's why work done in the first case is 0 joule. Next we have a boy or a man runs carrying a box with speed 3 meter per second to catch the bugs. Now the mass is moving with some speed. So in this case energy gained or work done is equals to kinetic energy, which is half mv square. Why? Because mass is there and it is moving with some velocity. So half mass value is given as 20 and velocity square we have 3 square. So here it is cancel out 10. 10 into 3 square means 9. So here we got it as 90 joule energy gained by box when the boy or a man is moving with speed 3 meter per second. Now we have to calculate the energy gained when the box is raised by 0.5 meter in order to place inside the bus. G value is given as 10. Here the height is raised. Height is raised means it is a form of potential energy. Potential energy we have mgh. Mass value is 20, g value is 10, and h value we have 0.5. So 0.5 we write it as 5 by 10. So cancel it out, we got it as 100 joule. So potential energy gained by a box of mass 20 kg when it is raises to 0.5 meter is 100 joule. Clear? Next we have a bullet of mass 50 gram is moving with the velocity 500 meter per second. It penetrates 10 centimeter into a still target and come to rest. Calculate the kinetic energy possessed by a bullet and average retarding force offered by a target. So here what we have to calculate, first we have to calculate kinetic energy and average retarding force offered by a target. So calculate first kinetic energy. A bullet of mass 50 gram, mass is given as 50 gram. Let's convert it into kilogram. We have to divide it by 1000. So divided by 1000 we got as in kilogram, that is 1 by 20 kilogram. So mass value we given as 1 by 20 kilogram. Now we have to calculate kinetic energy. Kinetic energy of bullet we have half mv square. So half mass value is given as 1 by 20 and velocity here it is given as 500 meter per second. So 500 square. So this is 1 by 40. 500 into 500. So cancel it out. Multiply this. So we got 500 into 50 divided by 4. So here we got 6250 joule. So kinetic energy of a bullet, initial kinetic energy of a bullet is 6250 joule. Now next we have to calculate the average retarding force offered by a target. What is the meaning of this? Carefully see. In the a block is there, a bullet penetrates in the block and come to rest at the last point we have 10 centimeter. So this block is applying some retarding force, only then this bullet come to rest. If this block will not apply any retarding force, then the bullet will not come to rest. So it means that the whole energy, the whole kinetic energy is overcome, or it's converted or absorbed by this block. It means that energy replied, or energy applied by the block, is equals to the initial kinetic energy of a block due to conservation of energy. So energy which is there in the form of kinetic energy in case of bullet is fully fledged converted or fully fledged absorbed by a block, only then the bullet come to rest. So energy of block, that is force into displacement. The and kinetic energy we have calculated, that 6250 joule. So force we have to calculate. Displacement, in this case bullet displacement is 10 centimeter, converted into meter divided by 100. So we got it as 1 by 10 meter. Put the value of displacement as 1 by 10 meter and here 6250. So from here force value we got it as 62,500 Newton. Force we are calculating, so it is actually 62,500 Newton. So this is the retarding force, average retarding force offered by a target. Clear? Next we have a spring is kept compressed by a small trolley of mass 0.5 kg lying on a smooth horizontal surface as shown in the figure. When the trolley is released, it is found to move at a speed of 2 meter per second. So it is start moving with the velocity of speed of 2 meter per second. What is the potential energy did the spring possess when it is compressed? Now carefully see what is the question. Initially spring is compressed with the trolley. When you just leave the trolley, this spring apply the force on the trolley and trolley start moving in the forward direction with the speed of 2 meter per second. It is having mass 0.5 kg. We have to calculate what is the initially the spring, how much elastic potential energy stored in the spring. Clear? So according to conservation of energy, that spring energy is there which is stored in the spring is equals to the kinetic energy in which the trolley is moving. Spring energy stored, we have kinetic energy. Kinetic energy formula we have half mv square, half mass value is given as 0.5 kg and velocity we have 2 meter per second square. So 1 by 2, this is again 5 by 10 and this is 2 into 2. So here 2 and 2 cancel out, 5 cancel with 2 and here it is cancel with 1. So each and everything is cancel out. So spring energy initially stored in a spring is 1 joule. So this whole energy is converted into a kinetic energy. So in this way, by the law of conservation of energy, we can calculate one form of energy by calculating another form of energy. Here we have calculated the kinetic energy, but it is the potential energy stored in the spring.